A one-day-old chick can fit comfortably in the palm of your hand, but only about 42 days later, some fast-growing white feather broiler breeds can already be ready for market. When this cycle of just about 6 weeks is repeated across thousands of farms, the scale becomes enormous. In 2025, China sent about 18.32 billion poultry birds to market and produced roughly 31.27 million short tons of poultry meat, or about 28.37 million metric tons, making the country one of the largest poultry production and consumption markets in the world. But behind those billions is a much more difficult challenge. When tens of thousands of chickens live inside the same house, people cannot simply feed every bird, inspect every water line, or adjust the environment using traditional farming methods. Everything, from temperature and humidity to airflow, feed, and drinking water, has to work as part of a single integrated system. And that is why modern industrial chicken farms increasingly resemble massive automated production facilities. In major poultry-producing regions, such as Shandong, Liaoning, Hainan, and Jiangsu, the cycle begins when specialized transport trucks deliver one-day-old chicks to the farm. The chicks are moved into brooding areas that have already been prepared for their arrival. Those first few days may seem simple, but they are actually among the most critical stages of the entire production cycle. Young chicks cannot regulate their body temperature as effectively as adult chickens. If conditions are too cold, they may crowd together for warmth, while excessive heat, poor ventilation, or unsuitable litter conditions can also affect how well they eat, drink, and grow. That is why, instead of relying only on visual observation, many farms use sensors and environmental control systems to continuously monitor conditions inside the chicken houses. Large ventilation fans pull air out of the buildings. Air inlets regulate the flow of fresh air coming in. Heating systems are used while the chicks are young, while cooling and ventilation become increasingly important as tens of thousands of growing birds begin producing more and more body heat. But controlling the air solves only half the problem. Every day, the entire flock needs an enormous amount of feed, and more importantly, that feed has to be distributed relatively evenly. This is where another network of machinery takes over. At feed mills, ingredients such as corn and soybean meal are ground, measured, and mixed with oil, vitamins, minerals, and essential amino acids. But chickens do not eat the same formula throughout all 42 days. As their bodies change, their diets change too. Feed can be adjusted for different stages of development to meet changing requirements for energy, protein, and other nutrients as the birds gain weight. Once produced, tons of feed are transported to farms in bulk trucks and pumped into enormous silos located outside the chicken houses. From there, workers barely need to carry feed to individual feeders at all. Electric motors power augers and feed lines, moving feed from the silos into the chicken houses and distributing it along rows of feeding pans. A single system can deliver feed to tens of thousands of chickens. Drinking water operates through a separate network. Long pipes running through the chicken houses are fitted with rows of automatic nipple drinkers. When a chicken activates a nipple, water is released as needed, eliminating the need for workers to constantly refill individual troughs. But here is the surprising part. Feed and water do more than keep the chickens alive and growing. They also become sources of data. If water consumption inside a chicken house suddenly drops, or feed consumption changes unexpectedly, farm managers can treat that as a signal to check flock health, the water supply, the feeding system, or environmental conditions. At a scale of tens of thousands of birds, even a tiny change multiplied across the entire flock can turn into a major problem. That means the farmer's job changes as well. Instead of spending most of their time carrying feed and water from one area to another, workers inspect equipment, monitor data, observe flock behavior, track body weight, and look for anything unusual. The goal is to keep an enormous biological system operating as steadily as possible, and the clock keeps ticking. From the tiny chicks that arrive on day one, the flock grows rapidly, week after week. Space that seemed abundant when the chicks first entered the farm gradually fills with thousands of growing chickens, approaching market weight. For some fast-growing white feather broiler breeds, this entire process can take only about 42 days. That speed does not come from any single factor. It is the result of decades of selective breeding, combined with stage-specific nutrition, environmental control, health management, and increasingly precise farming systems. But not every chicken in China is racing against that 6-week clock. Alongside white feather broilers, China also raises yellow feather chickens and many local breeds that serve very different culinary preferences. While white feather broilers can reach market readiness quickly, some yellow feather and local breeds are commonly raised for around 90 to 120 days, depending on the breed and production system. One side is heavily optimized for rapid growth and production efficiency. The other follows a longer production cycle and serves markets that place greater value on meat characteristics, texture, and traditional flavor preferences. Two very different paths, but both eventually lead to one of the largest scale stages of the production chain. Once broilers reach their target weight, they are caught, placed into transport crates or modules, and moved by specialized trucks to processing facilities. Here, the pace of the farm is replaced by the pace of an industrial processing line. The chickens are received and moved through slaughter, cleaning, chilling, and grading under hygiene and food safety control procedures. The final product may remain as a whole chicken or be cut into portions such as breasts, thighs, and wings, as well as processed into many other products before entering the cold chain. From a chick smaller than your hand to food transported to cities hundreds or even thousands of miles away, which is hundreds or thousands of kilometers, the entire journey can take only a matter of weeks. But the true scale becomes visible only when that cycle is multiplied. One study of Chinese broiler producers recorded a company in Shandong producing around 150 million birds per year, while another company, operating across a broader area, reached roughly 520 million birds annually. At that scale, even a small improvement in feed consumption, growth rate, or survival rate can create an enormous difference when multiplied across millions of birds. But meat is only half the story of China's chicken industry, because on another farm, the goal is not to get a chicken to market weight in 42 days. There, the bird needs to perform a completely different job, day after day, for months at a time: lay eggs. In 2025, China produced approximately 38.56 million short tons of poultry eggs, which is about 34.98 million metric tons. To maintain this enormous supply, laying hens generally begin entering the laying stage at around 17 to 18 weeks of age, and a flock may reach roughly a 50% laying rate by 20 to 21 weeks. From that point on, the challenge changes. It is no longer about getting a chicken to gain weight as quickly as possible. Instead, the question becomes how to get thousands or even tens of thousands of hens to produce a steady stream of eggs every single day. And once again, machinery solves the problem of scale. In modern production systems, feed arrives through automated feed lines. Water flows through pipelines, but at the other end of the chicken house, another product is constantly moving out: eggs. Instead of workers walking past thousands of individual locations to collect eggs one by one, the eggs can gently roll onto collection belts running along the housing system. These conveyor belts carry thousands of eggs to a centralized collection area. From there, the eggs are inspected and may pass through equipment that grades them by size, weight, or quality before they are packaged and sent into the distribution system. Something that sounds incredibly simple, moving an egg from a chicken to a carton, becomes an engineering challenge when it has to be done with thousands or even millions of eggs while minimizing cracks and breakage and keeping the entire line moving efficiently. But after decades of focusing on making these systems more and more efficient, the egg industry is now facing a new challenge. And paradoxically, this challenge almost runs in the opposite direction from the old goal. How do you give chickens more space while still maintaining an industrial-scale production system? That is why cage-free systems are attracting increasing attention. In these systems, hens have greater freedom to move around within the housing area and can perform more natural behaviors than they can in conventional cage systems. But greater freedom of movement also creates new problems. The space has to be designed differently. Flock management becomes more complicated. Sanitation, biosecurity, egg collection, and production costs all have to be reconsidered. In other words, technology once helped the poultry industry manage more chickens with greater efficiency. Now that same technology is being used to solve an almost opposite challenge, giving the birds more space while still maintaining control over an enormous flock. This is still only one small part of China's vast poultry system, but it shows how the industry continues to evolve. From a one-day-old chick and a 42-day production cycle to silos holding tons of feed, miles of feed and water lines, which is kilometers of infrastructure, chicken houses containing tens of thousands of birds, and conveyor belts carrying countless eggs, the modern chicken industry has transformed a job that once depended heavily on manual labor into an increasingly mechanized and automated system. But perhaps the most remarkable thing is not any individual machine. It is the scale. A single chicken house can contain tens of thousands of birds. A single company can handle hundreds of millions of chickens every year. And across the entire country, China can send more than 18 billion poultry birds to market in just 1 year. If you were standing in front of 2 cartons of eggs, one cheaper carton from a conventional system and another more expensive carton from cage-free hens, which one would you choose? Let us know in the comments. But chickens are only the beginning. Because once we leave these enormous poultry houses behind and travel deeper into China's livestock-producing regions, we encounter an animal raised under an entirely different system. And this time, feed, temperature, and almost the entire living environment become part of an automated production line. Welcome to the world of China's pig farming industry. Pigs are one of the most familiar farm animals in the world, but in China, this familiar animal has become the foundation of an industry operating on an extraordinary scale. In 2025 alone, approximately 719.73 million pigs were sent to market, producing about 65.45 million short tons of pork, or approximately 59.38 million metric tons, the highest level of pork production ever recorded in China. Behind that enormous number is a livestock production system that is changing rapidly. Alongside international breeds such as Duroc, Landrace, and Yorkshire, China also has native breeds such as Meishan and Jinhua. Selective breeding and crossbreeding allow farms to pursue different goals in reproduction, growth rate, feed efficiency, and meat quality. But when a farm raises thousands of pigs, the challenge is no longer simply getting them to grow quickly. Feed, temperature, waste, and especially disease all have to be controlled on a massive scale. That is why many modern farms use silos and automated feeding systems, mechanical ventilation, temperature and humidity sensors, cameras, and digital management platforms to monitor their herds. Some systems even use image recognition and automated weighing to identify individual animals showing unusual signs or to predict when pigs will be ready for market. But one of the most unusual solutions emerged when farmers confronted another limitation: available land and biosecurity. Instead of expanding only outward, China has built multi-story pig farms. Some of these facilities rise from 7 to 17 stories, while the famous complex in Ezhou, Hubei, reaches an astonishing 26 stories. Inside, feed is transported automatically, livestock areas are separated, temperature and airflow are continuously monitored, and people and vehicles entering or leaving the facility must follow strict biosecurity procedures. This allows thousands of pigs to be managed within a much smaller footprint. But technology solves only the production side of the equation. Once the pigs reach market weight, they are transported to processing plants, where slaughter, chilling, cutting, and further processing move the pork into an enormous supply chain. And when that cycle is repeated more than 700 million times in a single year, the result is nearly 66.14 million short tons of pork, which is about 60 million metric tons. If a 26-story building can become a pig farm, do you think technology has taken livestock farming too far, or is this what the future of agriculture looks like? Let us know in the comments. But in the next industry, the goal is not to produce something just once at the end of the cycle. It has to be harvested every single day, from millions of dairy cows. One of the last places you might expect to find dairy cows is on the edge of a desert. In winter, temperatures can fall to around -4 degrees Fahrenheit, or about -20 degrees Celsius, while summer temperatures can climb as high as 104 degrees Fahrenheit, which is about 40 degrees Celsius. Yet in northern China, these dry regions have become home to enormous dairy farms housing thousands of cows. And these farms are part of an industry that produced approximately 45.10 million short tons of milk in 2025, or about 40.91 million metric tons. Breeds such as Chinese Holsteins and Holsteins play an important role in this system. But keeping a large herd producing milk every single day takes much more than good genetics. The challenge is supplying tons of feed, clean water, and a stable environment, then collecting milk from thousands of cows before this highly perishable product begins to lose quality. On modern farms, corn silage, hay, grain, and other nutritional ingredients are loaded into total mixed ration mixer wagons, blended into a uniform ration, and then distributed along massive rows of feed bunks. But the most impressive part begins when the cows enter the milking area. At one China Shengmu facility, reports documented around 8,500 lactating cows using 2 rotary milking systems with 90 milking positions, with the cows being milked about 3 times a day. Instead of workers moving from one cow to another, the cows step onto a massive rotating platform. As the system slowly turns, the milking equipment operates continuously, allowing large numbers of cows to move through in an almost non-stop flow. But the moment the milk leaves the cow, another race begins. It travels through a closed system, is rapidly chilled, stored in specialized tanks, and then transported by tanker trucks to a processing plant for testing, treatment, and further processing. From Holstein herds in dry, arid landscapes to rotary milking parlors operating every day, technology has helped China expand its dairy industry to a scale of more than 44 million short tons per year, which is more than 40 million metric tons. If you could see a farm like this in person, would you rather watch the massive milking system in action or see the entire process of caring for thousands of cows? Let us know in the comments.